Hello and welcome. This is going to be our homework help video for the systems of equations by graphing homework. The first question asks us, what will cause two equation systems to have no solutions? What about infinite solutions? Here's what I was looking for that. Let's say when two equations form two lines on a graph that are parallel, the system will have no solution except when the lines are right on top of each other. Those are called coincident lines. Then the system will have infinite solutions. All right, so that's what is causing a two-equation system to have no solution. What that means is that there's no combination of two numbers that'll make both of the equations true at the same time. And we can observe that graphically because the lines are parallel to one another. Except for when they're right on top of each other, then every solution to one of the lines is a solution to the other line, and each line has infinite points, therefore infinite solutions. Another way to think about it. All right. The next set of questions asks us to solve by graphing and then to state our answer as an ordered pair. Let's go ahead and try that with number 2. So what I'm going to do is just graph each equation separately. The point at -4 for this one. Its slope is 2/3, so up 2 over 3. Connect that up with a straight line. The next equation is y equals -1/3 x minus 1. Start at -1. Go down 1 over 3. Or I could go up 1, left 3, and it would keep that same slope. Connect those up with a straight line. Let's take a look at where they intersect. That right there is the point 3, -2. As easy as that. Let's see if there's one that looks maybe like it's going to be challenging. Let's take a look at number 5 real quick. 2x minus 3. So I go to my y-intercept of -3. Slope of 2 is the same as going up 2 over 1. I'm all the way off the graph that direction, so I can also go down 2, backwards 1. Connect those up. Next equation's got a y-intercept of 1, up 2 over 1, up 2 over 1, down 2, backwards 1, down 2, backwards 1. Connect up these lines, and we can see pretty clearly that these two lines are parallel. And we know they're parallel from the system because parallel lines have the same slope. We can see that these have got the same slope. These are parallel. So what should we say for our answer? Where do two parallel lines intersect? No solution. Let's take a look at some of these. Numbers 8 and 9, same concept, but now they've been given in standard form. Before we graph these, we got to convert them to slope-intercept. Sorry. All right. So I'll do that in the margins. 5x minus 2y equals -4. We get this slope-intercept form, so I might subtract the 5x from both sides. And divide both sides by -2. Now y is by itself, and the other side looks like slope-intercept form. 5 halves x plus 2. Try that again with my other equation. X plus 2y equals -8. Move the x over. 2y equals -x minus 8. Get rid of the coefficient. Y equals -1/2 x minus 4. Time to go to the graph. First one, y-intercept of 2. Slope of 5/2 means up 5 over, rise over run. Yeah, up 5 over 2. That's off the graph, so I could also go down 5, backwards 2, and it'll stay in that same trajectory. I'll connect those up with the straight line. So we'll keep it purple. Next equation's got a y-intercept of -4. Slope of -1/2, so down 1 over 2. I'm off the graph this way, so I could also go up 1, backwards 2. Connect these up with a straight line. And we can see where they intersect. It's this ordered pair right here. Switch to green, here we go. That's the ordered pair, -2, -3. And that's our solution. All right, the last section says try in your graphing calculator. State your answer as a y equals and an x equals. So it's a little different way of doing this. I'm also noticing number 11 actually can't be done in the graphing calculator. This one, sorry about number 11 here. This one you could do by hand. X equals -4 is going to be a vertical line at -4. And then we just need to see where this line intersects it. Y-intercept of 2. And it's going to intersect somewhere back here. Actually, I mean, this would be easiest to do a substitution. I know we don't know substitution yet, but you plug in the -4 there to find this value. And we'll get 2 plus 2 for 4. So this is the intersection point. X equals -4, y equals 4. All right, so that was number 11. Sorry, we can't do that with the graphing calculator, but these other ones we can. Let's go ahead and get on our graphing calculators. For this first one, I'm going to press y equals. Any equations that are already in there, I'm going to clear out by just going to the equation, any part of the equation, and pressing clear. I'm going to get rid of the whole thing. I'm going to enter the top equation as y1, just the right-hand side of it, and for the right-hand side of this equation, 3x minus 4, -2x plus 1. Now, to get an idea of where these intersect, I could look at the table, or I could see if just zoom 6 shows the intersection point. Once again, that's zoom and then the number 6. And we can see that, yes, zoom 6 does show where these intersect. So now I can just use second trace, number 5, and then select the first line, select the second line, take a guess, somewhere around there. See that these intersect at 1, -1. And it asks us to give our answers as x equals 1, y equals -1, and not make this an ordered pair. All right, that should be good for this homework. Have a good rest of your day.